Here we go, multiple choice. Make sure that you know how to answer conceptual questions about simple harmonic motion. So these are pretty straightforward also because you're going to have that table. So at maximum displacement, what is the acceleration? Is it maximum or is it zero? Like more conceptual, not the actual number value. Maximum. Okay. Yes. So be able to answer those type of questions given that you'll have that available.
Acceleration would be zero.
Correct.
At maximum.
Theta.
No. Well, which one? What are we doing?
I need help. At maximum acceleration.
Yeah, at maximum, acceleration is max. If there's a formula, then that's maximum. If it's zero, then it's zero.
Okay.
Is there anything other than
No, those are conceptual ones. Not going to have you calculate those. Okay? So just know where to look. Okay. Gina. No. Right triangle. Yeah. Here? Oh, because even though it stops, the force is the greatest at that spot. So it has the moment it starts moving, it has its greatest acceleration. It's just going, there's a difference between how fast and the potential to accelerate. Right, but it stopped. You can actually be sitting still but accelerating. I know it seems weird. No, it's not that. At this moment, when it's at the peak, it stops, right? But it's accelerating its greatest at that spot, even though it's sitting still. It has the potential to accelerate. Okay. Audrey. I'm not sure. But I can't hear her because so much talking is happening.
Okay, so imagine you could transport a simple pendulum from Earth to the moon where the free fall acceleration is 1/6 of that on Earth. What factor would the pendulum's frequency be changed? How do we, do the math?
Okay. So gravity.
Do we need to know how to do it?
Yeah. Okay. So that's the period of a pendulum.
No, I'm wrong. This isn't
Okay. And we're just changing gravity, right? Nothing else. Okay. So go to the moon, and that's what you get, right? So overall, if everything else is the same, the period is impacted by that much. Okay? So by the square root of 1/1/6.
So the square root of 6?
Yep, which is equal to the square root of 6, which equals some number. But, wait a minute, Audrey, what was the question? How much does the what change? The frequency. So frequency is not...
So it's square root of 6 over 6. There we go.
Yep, so that's how you figure it out.
Wait. Walk me through that last step.
All right. Period and frequency are inversely related. So this is the equation for period. Get to the finish line and then invert it, put a 1 over it to find the frequency. Okay? Any other questions about multiple choice type concept type thing before I review a couple more? That was a good question. Gina?
Did we get that equation?
Yeah, pretty sure. It's not on that sheet. I will make sure to post it. That's because it's probably not, it's not a free response question, so I can make sure to post it. I can post that too. Same thing, that's not, you're not gonna have a, like a free response question, that's where that gets derived from. Sign vote.
Yeah, though.
I don't believe so. I'm gonna say no, and if there is, I will have to adjust. No double batteries. Shopper.
You're putting light and sound, we're in cold.
Yes.
Can you not?
I know. Just absorb. Just feel it. Feel it. But you know what? They're naughty. They're all talking. They're just driving me crazy. But they're here. Moving on. Hopefully that didn't get recorded. Although, after Kosa's full pod today.
Yeah, so we have two very interesting things going on right now. Wait, take those videos down. Are they recorded? Yeah.
Yes, it is. All right. What, there was a question somewhere at some point. What was it? Stop talking, guys. Who had a question that I didn't answer? Shabba.
Are you gonna put a lot of light and sound questions on this?
Sure.
That one,
How about I review light and sound?
can you actually sound and
Sound and vision? Oh. Glad to help out when I can. All right. Do you know all your wave parts?
Yeah.
Yeah, these are the nodes. Anti-nodes are basically these spots. Okay. What's that? I didn't draw it very well, but wavelength. Yep, that's wavelength. Sorry, it's not perfect. Sorry. No, it goes from. Yeah, that's right. There we go. I got it. Right, that was
Qualified to give us this final.
not right at this moment. I had a hard day.
Yeah, we know. Look, guys, I did it.
All right, crest to crest. Don't do that. Yes.
Is it like breast to breast?
There, I know they look like boobies. I get it.
We take them for like 2 seconds, we take them to cheers.
Sure.
Not like super loud.
Not super loud. I don't know if they can do that.
I am very unique.
You want to help out these seniors so they can graduate?
Yeah.
Okay, tell them what to do.
A short clip of you all like cheering, like
Woo! Why are you both dressed like ninjas?
superheroes.
Okay. Okay. All right. All right. Okay.
5 seconds to say.
Now let's play.
Fair pride, babies. Here we go.
1, 2, 3.
Good loud clapping. Okay.
We did it, everyone. Whatever it was, we did it. And we're stretched.
Yeah, sweet. You could. I could teach you how. I could teach you. Okay. Just letting you know. Just letting you know. I know that was very distracting. All right. But I still have to like copy your exam. And so at 4:45, maybe 4:50, this session is over. So the longer you like la 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 la, the less stuff you're gonna get from me.
Can we do the light and sound?
Yeah, I'm trying.
When you go over the new,
Oh, sure, that's a good idea, yeah. So there's two different types of waves. These are transverse, these are longitudinal, light wave, sound wave, right? And there might be a question where, and I ask you like to compare, so the compressions line up with the what? The crests or the troughs? Crests. And the rarefactions line up with? Trough, yeah, that's a rarefaction, that's one over here. Those are rarefactions. And the compressions are the more dense areas. It's better on the test, okay?
Oh, okay, I see what you're saying.
Yeah, compression, rarefaction. High pressure, low pressure. Oh, yeah. Well, in this particular picture, but not always. Just this particular picture.
What is the?
I could shift him 180 degrees out of phase. Okay. Yes, this is longitude. Madison had a very good question. What if we put two waveforms together? Could you figure out the interference pattern?
Apparently I can. You gotta draw. You gotta like add it. It's
Oh, I remember, like, yeah, and I got it right, and I felt like,
no, but I mean like it wasn't. No.
figure it out, turns out I did, I wasn't doing what I was doing, I wasn't solving it the right way.
All right, this is supposed to be like this. Sorry.
Oh, so this is transposing? Is this transposing it?
Yes, put them together. Well, I don't know why he ran away. All right. Okay, so can we do this? On this, I'm going to draw it over top of this one. So what should this first little section look like?
A little bit lower, right?
Yeah, it's a trough, but it's not as much amplitude. Yep. And if these are perfectly even, we're going to pretend like they are. Then what? Flat line. And then what happens here? A little bit of trough. That's right. Okay, I don't know what that is. Pretend like that's not there. Okay? Can you do that, Tomorrow? All right. Say thank you, Madison. That was a nice hint. That was a nice hint.
Thank you, Madison. Thank
How do we say frequency in sound? Pitch. What are the units for frequency? Hertz is correct. Yes. Maybe. You did? No ambulance. I don't have enough paper for that. Our paper limitations. Okay. So no ambulance question, but you should know Doppler effect. So, yeah, like bug on the puddle. So if a sound source is moving toward an observer, the pitch to the observer will be higher. Good. The sound source itself, same, and someone that's moving away, so if you know that much, you should be fine. Okay. Is there such a thing as the Doppler effect in light? Yes, the same phenomenon occurs. Instead of higher pitch, what will you see? Higher frequency, which is the other side of the spectrum. High frequency light is what color? Blue. So as a light moves toward an observer, the waves get compressed, and that's higher frequency, and that's blue. Yeah. And as it moves away, the frequency will get lower, and that'll look red.
Is that why they use blue and red?
It's called redshift blue shift. It only really occurs at very, very distant sources because the speed of light is really fast. And so, like, if I run with a flashlight around the room, you're not going to notice because I can't run fast enough. But as the universe expands, we can get a feel for how fast it's expanding because of that color shift. So, Bailey Bear? Oh, this is a good question. That is a good question.
It's not yellow, red, and blue.
I don't know, I didn't do that. I would never.
Shut up, Nick, I'll let. What about the color spectrum?
Yeah, I know, I'm looking. Yeah, there's some color stuff. Listening. Yes, there are some color questions. Sure. And this is not on your equation sheet. So the circles are 3 primary colors of light transmission. Yep. So these are, if you look up close at the pixels on a computer or television, those are the 3 colors. In the middle, where all 3 come together, what color? White, that's correct. This is light transmission, not light absorption. What do you get when you put red and blue together? Magenta. What do you get when you put green and blue together? Cyan. And this is a weird one. Red and green. Yellow. Okay. Yeah. Yep. So if you, listen guys, here's a big fat hint that'll help you a huge amount. If you can remember this and like download it like I told you to do with the harmonics charts, it will help you answer the question. You want to see how?
Yeah, sure.
Okay. So, first of all, if I asked, what are the 3 primary colors? Red, green, and blue. What are the 3 secondary colors? Good. And put them all together and you get white. All right. If I put a green object under a green light, it looks green, because that color is available for reflection. So anything that's in this green circle will look green. So green under green light, green under yellow light, green under white light, green under cyan light, green under blue light, good, black. So if the color's not available, it's going to look black. It's going to absorb instead of reflect, okay? Now, there are harder ones than that. Yeah, you're okay with, yeah, it's just light transmission. So, does that make sense? So, see how if you actually can write this down, it'll help you answer those questions? A yellow light, yellow object under green light will look green because it has like green and red pigments, but the green will reflect and the red will absorb, so it'll look green. Okay? So that's it for color. These, sure. What will a blue object look like under red light? What will a blue object look like under magenta light? Oh, thank you. Yeah, that's hers. Mr. Meese said that a Calc BC kid left a cheer sweatshirt. Well, he said it looked pretty small, but really, cheerleaders, Calc BC. Oh, Bailey, that is. Come on, hold the calculus rope, right? And RC, right? Are you both in BC next year? It still counts. It's still calculus. I'm still claiming it. Okay.
Are you indirectly calling the cheerleaders?
No. If I had had them when they were younger,
Yeah.
that way.
I could have built them.
That's right, if I could have molded them.
They were not my creation.
Oh, yeah, I'm gonna talk about her because she's not here. When Annie was like 4, she was sitting on the stairs, asked me to carry something up the stairs for her. She was 4. And I'm like, no, you carry that up yourself, you know, you're a big girl. And she's like, no, people tell me I'm cute. I don't have to do, I'm like, what? So, she got over that. 4! We're conditioning our women like that. Like, who did you hear that from? I will kill them now.
Oh, well, hold on there. Let's take this a step back.
All right.
That might be a bigger task. Hold on.
You want to do some physics?
Yeah.
All right. So, let's do a sound that's twice as loud.
Oh, decibel intensity.
Decibels versus intensity. Remember how to do those?
The nightmare. The nightmare.
Loud, right. Decibels. You can't see that. And intensity. Got it? So, 2 times louder is how many decibels?
20.
Uh-uh.
No, it's you. 10.
Yeah, it's a change of 10 decibels.
Ah.
It's a change. And how much more intense is it? Yeah, well, no, it's 10 times louder. Does that make sense? It's 1 decimal place. It's 1 decimal place. It's an extra decimal place. Yeah, it's 10 decibels and a decimal place for this. They're different. So now if I go 4 times, how many decibels louder? 20. And how many? 100 times the intensity. That the X means times. Okay? Got it?
Got it.
All right. No, this would be a question. A sound is twice as loud. How many more decibels will it pick up? 10. Yes.
Way to read, Josh. This question is better left unanswered. No.
All right, then. I trust you. Okay. Just listen, guys. Looking at the exam, there are concept questions that it would be really helpful if you had those resonance, simple harmonic, open, open, closed, closed, open, closed. If you have that diagram, just look at them like, oh yeah, if I had that diagram, be able to answer that. 3 is fine. That's a good question. 3 is fine. There are also some simple math questions, like
4. Easy.
like how many beats? You are a quirky person. How many beats are there if I have 2 tuning forks, one 440 and one 444? Yes, 4. Just subtract. Yeah, it's the absolute value of the difference. Yeah. Okay. 50 multiple choice and about a dozen-ish free response. I can't remember exactly, but yeah, this will take, I will tell you, babies, listen, strategy-wise, this is about an hour and a half, and it's going to take the whole hour and a half. Yeah. Yeah, so be smart about this. If it's 50-50, and it is, and you have 54, half the test is a dozen free response, and the other half is 50 multiple choice. Well, how should you split up your time?
You look at how many points.
Yeah. So what do you think about the free response in terms of points, bang for buck there? Yeah. I can't curve multiple choice. I can be a little more generous with free response. So I would say, strategy-wise, do the free response first. Give yourself at least 45 minutes to do that. If you go a little over, you're going to get more points out of the free response, because I can give you partial credit. And then you can always just randomly circle C for the multiple choice if you get to the last 30 seconds, right? All right. There was a question. Who had their hand up? I'm not conscious of it, so, sorry. Go ahead, Gina. 50. Yeah, don't run out of time, though, if you have free response left, because you're not going to really get much points for that, right? So I would flip the order and do the free response first. Okay, other questions? Yes? Maybe. You want one? Oh, that's right, you're music kid.
Can it be on?
I don't.
And then like worth like.
5 points.
Like maybe an entire test based on
I should-
whether it's a harmonic or not.
I should make first hour answer questions about the confrontation song.
Oh my God.
Please
Yeah,
don't.
what are the lyrics?
Let us nip it in the bud. Well, no revolution.
People die.
All right.
Please no harmonic sound stuff. I don't have any whatsoever.
It's just, sometimes you have to just go with your strengths and,
I have a mathematical mind, but not a
I know. I will tell you this, big hint, and here's a hint. This might be the last thing, too. Know the relationship between voltage, current, and resistance, all three of those for series and parallel circuits. Yep, so let's do that real quick. It's not very hard to do. They are. So, series and parallel resistors, that is on your equation sheet, right?
Yeah.
So for series, what's total resistance? Parallel? In series, so these are on your equation sheets, but that's it. So I'm probably more likely to ask you other stuff. So in series, total current equals what? There's one path. It's the same all around. So it's like this. Okay? Right? Same current, so there's only one. And how about parallel? Add them up. And then voltage is the opposite. Add it up, that's right. Voltage total equals V1 equals V2 equals V3. Okay? Those would be good to know. Know your mirror and lenses, guys.
Can you explain how you know whether it's supposed to go like this, or whether it's supposed to, you know how we have them like this?
Yeah.
And sometimes you go down, and then sometimes
Yeah.
Stop, guys. Right now, we know this will
Yes. Yes. Jillian, you asked a good question. Converging means that when the light comes in, it does that. Okay?
Ms. Nick, are we just like answer questions?
Well, I'm actually going to be kicking you out in about 2 minutes. And converging mirror is one of these. I don't think so, but if there